Welcome, welcome. We have this radical equation here, square root of 8 plus square root of 48 under the square root. And it is giving us the square root of a number x plus the square root of another number x. Now we want to find the value of these numbers, x and y. How do we go about that? So the first thing is to square both sides of the equation. So let's do that. We'll square both sides of the square root equation. So I'll square this side and I'll square this side as well. So remember that when we have this perfect square, a plus b all squared is equal to a squared plus 2ab plus b squared. That's what we are going to use for the right hand side of the equation. We know that this square can get rid of the square root. So we have 8 plus square root of 48 on the left hand side of the equation. Now a is square root of x and b is square root of y when we compare this to this. So a squared will be square root of x squared. Then plus 2ab. A is square root of x. B is square root of y. Then we have b squared, square root of y squared. So this will get rid of this. Square will undo the square root. Then you recall that square root of a times square root of b is equal to square root of ab. So by extension, square root of a times square root of b times square root of c will be square root of a, b, c. So that is what we are going to apply here. So we are going to rewrite the 2 as square root of 4 plus. So we have square root of x times square root of y here, and we have plus y over here. Now we have x here, then we have 8 plus square root of 48 here. So we have to rewrite this. We have 8 on the left hand side plus square root of 48. Then we have x plus y. Then we have square root of 4x y using this property of square roots. Now we can compare this to this. That will give us x plus y is equal to x plus y is equal to 8. Since we have two variables, we can name this equation 1. So we need to get another equation. So we can just do that by comparing this to this. The values under the square root sign, the radical sign. So that will be 4xy is equal to 48. So dividing through by 4, 4 will go into 48 12 times. 4 will go into 4 once. So we have xy is equal to 12. So we can call this equation 2. By inspection, we have two numbers that when you add, you get 8. And when you multiply, then you get 12. By inspection, we can see that the numbers must be 2 and 6. But how do we show that the numbers are actually 2 and 6? We have to solve the equation simultaneously. So we can make y the subject in equation 1. So y will be equal to 8 minus x. So we can call this equation 2. We plug in equation 2 into equation, and we call this equation 3. So we plug in equation 3 inside equation 2. So x, y, the y is now 8 minus x is equal to 12. We expand. X times 8 is 8x. X times x is x squared is equal to 12. So we have negative x squared plus 8x minus 12 is equal to 0. Rewriting it in the quadratic form, the standard quadratic form. So multiply through by negative 1, we have x squared minus 8x plus 12 is equal to 0. So we can factor. So in factor, we split the middle term, x squared minus 6x minus 2x plus 12 is equal to 0. So we have x into x minus 6, then minus 2 into x minus 6 is equal to 0. So we have x minus 2 into x minus 6 is equal to 0. So either x minus 2 equals 0 by the zero product property, or x minus 6 equals 0. So x is equal to 2 or x is equal to 6. Now when x is 2, y will be equal to 8 minus 2, which is 6. And when x is 6, y will be equal to 8 minus 6, which is 2. So the value of x and y are either x equal to 2 and y is equal to 6, or x is equal to 6 and y equal to 2. So that implies that the square root of 8 plus square root of 48 is actually equal to square root of 6 plus square root of 2.